So, you did it. You went through all the trouble of building your own microbial fuel cell. Everything's in place, the chambers are sealed, and nothing. It's just sitting there, right? A fancy paperweight that's not producing a single drop of power. It's a super common problem, trust me. But the solution? Well, that's where the fun begins. It's time to bring that thing to life. So what's the missing piece of the puzzle? You've built a house, you've got all the equipment, but right now, your fuel cell's basically an empty building. To get power flowing, you don't need a fancier wire or a different kind of battery. No, what you need is an army. And guess what? You're the general. See, the missing ingredient is a living, breathing, power-generating force of microbes. And your job is to recruit them, train them, and deploy them. So let's get into your mission briefing.
Okay, General, here's the mission. We're going to walk through the exact strategy to awaken your MFC. The goal here is to turn that dormant cell into a power-producing machine by building your very own microbial army from the ground up.
Every great army starts with finding the right soldiers. And in our world, these soldiers are a special kind of bacteria called exoelectrogens. These are incredible little microbes that can basically breathe metal. They transfer electrons outside of their own cells. Think of them as your special forces. We're talking about species like Geobacter and Shewanella, and you can find them in some pretty specific and, yeah, kind of muddy places.
So, where do you go to find these elite recruits? You've got three main recruiting grounds. First up, the best of the best. Anaerobic sludge from a wastewater treatment plant. You know, that oxygen-free, super microbe-rich gunk? It's packed with a huge diversity of bacteria, so you'll get a really quick start. Next, you could grab some sediment from a local pond or a lake. This is a great choice for getting natural, stable communities of microbes, but they do take a bit longer to get up and running. And finally, for the budget-friendly, easy-to-access option, you can just use compost or soil from your backyard. Just know that it's going to be a slower process because your key soldiers are a little more spread out.
And just to give you an idea of what we're aiming for, here's the kind of potential we're talking about. If you get your recruits from that top-tier anaerobic sludge, you could be looking at a power density of around 1 watt per square meter. That's according to some 2009 research. And for us, that's our first mission objective. Not bad, right?
All right, so you've got your recruits, but you can't just toss them in there and expect them to work. Nope, you gotta put them through boot camp first. We call this the enrichment process, and its whole purpose is to weed out the weaker microbes and train up only the absolute best power producers for your elite bioarmy.
Now, this training program has 4 critical steps. First, you gotta provide rations. We're gonna feed them a simple fuel, like acetate. Second, you apply pressure. By connecting a 1,000 ohm resistor, you're basically forcing the microbes to generate a current if they want to survive. It's tough love. This is what selects for your superstar exoelectrogens. Third, you've got to monitor their vitals. We'll do that by tracking the voltage. And last but not least, maintain the barracks. This means keeping their home warm and, this is crucial, completely free of oxygen.
Getting these boot camp conditions right is absolutely make or break. You're going to use a 50-50 mix of your inoculum, that's your sludge or your sediment, and a medium that has about 1 to 2 grams per liter of acetate. You need to keep the pH right in that sweet spot, somewhere between 6.8 and 7.2. The temperature should be nice and cozy, between 25 and 35 degrees Celsius, and remember, it has to be anaerobic. A good way to do that is to bubble some nitrogen through it.
So how do you know if the training is actually working? Simple. You watch the voltage. In that first week, don't expect much. It's going to be low. But as your army gets stronger and more disciplined, you'll start to see that voltage climb. Your sign of success, the graduation certificate, if you will, is a nice, steady voltage, somewhere between 0.1 and 0.5 volts. You should see this happen within about 1 to 4 weeks.
Okay, your army is trained, they're ready for action. Now it's time for the final and maybe the coolest phase, building their base of operations. But this isn't just some structure. We're talking about a living, breathing power grid that literally grows right onto your electrode. We're talking about the biofilm.
So what in the world is a biofilm? Well, think of it as a city built by your microbes, a self-assembling, living extension of your electrode. This incredible structure creates a superhighway for electrons to travel down. We call this process extracellular electron transfer, or EET. This is the critical piece of infrastructure that lets your army deliver power at peak efficiency.
And just get a load of the impact a good biofilm can have. A healthy, mature one can increase the effective surface area of your electrode by 10 to 100 times. This is a total game changer. More surface area means more spots for your little soldiers to dock and transfer their electrons. And that directly translates into way more current and a whole lot more power. It's like getting a massive hardware upgrade built for free by your own microbial army. And this is where we really ramp up our mission goal. With a mature, thriving biofilm, the ultimate prize comes into sight. Research has shown that systems with these well-developed biofilms can reach power densities of up to 5 watts per square meter. That is a massive jump in performance from where we started. Now, to help your army build this incredible power grid, here are a few pro tips. Try to use electrodes with rough surfaces, like carbon felt or graphite brushes. This gives the microbes something to grab onto. Also, maintain a gentle, constant flow of their food source. And, be prepared to do a little maintenance. Sometimes these biofilms get a little too good at growing, and you might need to clean away some of the excess.
Of course, no mission ever goes exactly according to plan. You're bound to run into some challenges out there in the field, but the key is to stay calm, know what to look for, and keep your army in a state of operational readiness.
So here's your quick reference field manual. If you're getting 0 voltage, the first thing to check is your connections. Simple, but it happens. If those are solid, your army might have gone AWOL, and you might need to re-inoculate. If your voltage is jumping all over the place, it's almost always a pH problem. Just add a bit more buffer to stabilize things. And if everything just seems to be starting up painfully slow, your troops are probably just hungry. Give them a boost of acetate.
All right, let's debrief this whole mission. What are the big takeaways? Number 1, recruit your army from the best sources you can find, like anaerobic sludge or pond sediment. 2, train them. Put them through boot camp with acetate and an electrical load. 3, monitor your progress. A steady rise in voltage is your sign of success. 4, build that living power grid by helping that biofilm grow. And finally, maintain everything by keeping the conditions inside your fuel cell consistent.
So if you followed these steps, that silent paperweight you started with is now a living, breathing, working power source. Your microbial fuel cell is officially alive. The microbial army has been activated. Mission accomplished, General. But a general's work is never really done. Your army is assembled, they're operational, but an army needs fuel to keep fighting. So the real question now is, are you ready for the next campaign? What are you going to feed them?